Ribbons in the sky, unveiling plasma jets from a supermassive black hole binary. What if everything we thought we knew about black holes was just the beginning of an even more mind-bending reality? Cosmic Ribbons Unveiled. Revolutionary Space Observatory exposes the twisted dance of twin monster black holes. News, 30 July 2025. Picture this. Somewhere in the vast cosmic ocean, 5 billion light-years away from your morning coffee, two supermassive black holes are locked in an eternal gravitational waltz. And now, for the first time ever, we've actually witnessed the spectacular light show they're putting on. An international consortium of astronomers has just unveiled the most breathtaking, high-resolution glints yet of a serpentine plasma stream erupting from the core of OJ-287, a mysterious active galaxy that's been keeping scientists awake at night since the 1880s. Using the groundbreaking RadioAstron space telescope working in perfect harmony with 27 Earth-based radio observatories scattered across the globe, researchers have essentially created a cosmic magnifying glass 5 times wider than our entire planet. The result? A resolution so sharp, it's like being able to read the fine print on a magazine in New York while sitting comfortably in Delft, Netherlands. But here's where it gets controversial. This isn't just any ordinary black hole we're talking about. OJ-287 is suspected of harboring not one, but 2 supermassive black holes in its central region, with their combined mass exceeding a staggering billion times that of our Sun. Think about that for a moment. We're dealing with cosmic titans that make our Sun look like a grain of sand on an infinite beach. The research findings, freshly published in the prestigious journal Astronomy Astrophysics, represent the collaborative efforts of brilliant minds spanning Spain, Germany, the Netherlands, South Korea, Italy, the United States, and Russia. Among them stands Professor Leonid Gurvits from Delft University of Technology, whose dedication to this project is nothing short of extraordinary. I joined the project in 1979, before many of my co-authors were born. Gurvits reveals, highlighting the decades-long journey that led to this breakthrough, a universe-sized telescope network. To understand why OJ-287 is such a cosmic celebrity, imagine trying to observe 2 invisible dancers performing an intricate routine in complete darkness. That's essentially what astronomers face when studying black holes. These gravitational monsters are completely invisible to our eyes. However, their presence becomes unmistakable as they voraciously consume surrounding matter, creating spectacular fireworks displays as gas and cosmic debris heat up to unimaginable temperatures before disappearing forever beyond the event horizon. The revolutionary RadioAstron mission has transformed our understanding by linking a space-based radio telescope with ground observatories worldwide, creating what scientists call a virtual telescope. With unprecedented capabilities, this cosmic collaboration has revealed not just the intricate ribbon-like structure of the plasma jet, but also identified regions within it that reach temperatures exceeding 10 trillion Kelvin. To put this in perspective, that's roughly 600,000 times hotter than the Sun's core. Temperatures so extreme, they challenge our understanding of physics itself. Witnessing cosmic violence in real time. And this is the part most people miss. The team didn't just capture a static image. They actually observed the birth of a brand new shockwave within the jet, watching it travel along this magnificent cosmic ribbon until it collided with an existing stationary shock. This collision wasn't just visually spectacular, it coincided perfectly with the historic detection of trillion electron-volt gamma rays from OJ-287 in early 2017. the most energetic gamma rays ever recorded from this source. Dr. Salia Triano from Heidelberg University captures the excitement perfectly. We captured the birth of a jet component and watched it travel down this beautiful ribbon until it hit a shockwave and produced the most energetic gamma rays ever detected from this source. The polarization measurements revealed something equally fascinating. The jet's magnetic field runs parallel to its length, providing crucial new insights into how these cosmic jets are launched and sculpted by their parent black holes. The binary black hole mystery. Here's where the story takes a truly intriguing turn. Since the 1880s, yes, you read that correctly, over 140 years ago, OJ-287 has been displaying peculiar brightness variations following a mysterious 60-year cycle. This regular pattern has led scientists to propose something that sounds like science fiction. The galaxy's core contains not one, but two supermassive black holes performing an eternal gravitational dance around each other. The newly captured jet imagery strongly supports this controversial theory. If two massive black holes are indeed orbiting each other within the galaxy's heart, their gravitational interaction could periodically twist and redirect the plasma jet, creating the observed variations. The detected twisting pattern aligns remarkably well with the long-term wobbling previously observed in OJ-287's jet, likely caused by precession effects driven by this same orbital motion. This makes OJ-287 an invaluable laboratory for studying how binary supermassive black hole systems evolve and eventually merge, a process that should generate powerful gravitational waves, those elusive ripples in space-time itself that Einstein predicted over a century ago. The future of cosmic discovery. But here's where it gets controversial. Are we ready for what comes next? The joint ESA and NASA flagship mission, LISA, Laser Interferometer Space Antenna, scheduled for launch in 2035, is specifically designed to detect these gravitational waves from space. When LISA becomes operational, we may finally have the tools to observe black hole mergers through multiple channels simultaneously, both electromagnetic radiation and gravitational waves. This research represents a crucial stepping stone toward what scientists call multi-messenger astronomy, a revolutionary approach that combines various cosmic signals including electromagnetic radiation, gravitational waves, and neutrinos to explore the universe with unprecedented detail and accuracy. Professor Gervitz offers a thought-provoking perspective. One of the beautiful things about fundamental science is the unpredictability of its impact. When electricity was discovered 200 years ago, no one could have imagined how deeply it would shape modern society. It's the same with our research. We don't know when and what its effects will be. But that uncertainty is part of what makes fundamental science so exciting. That said, it is certain that this RadioAstron study is a prelude to the upcoming transformational discoveries in the new era of multi-messenger astronomy. So here's my question for you. In an era where we can observe cosmic events that occurred billions of years ago with such incredible precision, what does this mean for our understanding of our place in the universe? Are we witnessing the birth of a new age of cosmic discovery that will fundamentally change how we perceive reality itself? And here's the part that might spark some heated debate. If we can detect and study black hole mergers happening billions of light years away, should we be investing more resources in space-based astronomy? Or are there more pressing issues here on Earth that deserve our attention and funding? What's your take? Is this the kind of fundamental research that drives human progress? Or are we getting carried away with cosmic curiosities while neglecting earthly concerns? Share your thoughts in the comments below. Are you team explore the cosmos at all costs, or do you think you should focus our scientific efforts closer to home? I'm genuinely curious to hear where you stand on this cosmic controversy. OJ-287, groundbreaking image reveals mysterious galaxy's heart. Imagine being at the edge of the universe, gazing into the heart of a mysterious galaxy that has puzzled astronomers for over 150 years. The OJ-287 galaxy, located a staggering 5 billion light-years away, has been a subject of fascination due to its unique brightness variations, which scientists believe are caused by the merger of two supermassive black holes at its core. But here's where it gets fascinating. An international research team led by Dr. Eftalia Traianu of Heidelberg University has recently captured the groundbreaking image of the galaxy's heart, revealing a previously unknown, heavily curved segment of the plasma jet spinning off the galaxy's center. This remarkable image, taken with the aid of a space radio telescope, provides new insights into the extreme conditions surrounding supermassive black holes. The core of the OJ-287 galaxy belongs to a class of highly active galaxies known as blazars, which are characterized by their striking luminosity. At the heart of these active galactic cores are black holes, which absorb matter from their surroundings and can fling it off in the form of giant plasma jets comprised of cosmic radiation, heat, heavy atoms, and magnetic fields. As Dr. Traianu, a postdoctoral researcher, emphasizes, we have never before observed a structure in the OJ-287 galaxy at the level of detail seen in the new image. The image, which penetrates deep into the galaxy's center, reveals the sharply curved ribbon-like structure of the jet, pointing to new insights into the composition and behavior of the plasma jet. Some regions of the jet exceed temperatures of 10 trillion degrees Kelvin, a clear indication of the extreme energy and movement being released in close proximity to a black hole. The researchers also observed the formation, spread, and collision of a new shockwave along the jet, which they attribute to an energy in the trillion electron-volt range from an unusual gamma-ray measurement taken in 2017. But what's even more intriguing is the method used to capture this image. The researchers employed a ground-space radio interferometer, consisting of a radio telescope in Earth's orbit and a network of 27 ground observatories distributed across the Earth. This virtual space telescope, with a diameter 5 times greater than the diameter of the Earth, allowed the researchers to create an image with unprecedented resolution. The image is based on a method of measurement that takes advantage of the wave nature of light and the associated overlapping waves. And this is the part most people miss. The interferometric image underpins the assumption that a binary supermassive black hole is located inside galaxy OJ-287, providing important information on how the movements of such black holes influence the form and orientation of the plasma jets emitted. As Dr. Traianu states, its special properties make the galaxy an ideal candidate for further research into merging black holes and the associated gravitational waves. Now here's a question to ponder. What do you think is the most significant implication of this discovery? And how do you think it will impact our understanding of the universe? Do you agree that the OJ-287 galaxy is an ideal candidate for further research? Or do you think there are other galaxies that deserve more attention? Share your thoughts in the comments below. But before you do, consider this. The merger of two supermassive black holes is a rare and extreme event, and the OJ-287 galaxy offers a unique opportunity to study this phenomenon up close. So, what are your thoughts on the significance of this discovery? And where do you think it will take us in our quest to understand the universe? Groundbreaking discovery. Twin supermassive black holes in OJ287 galaxy revealed. Unveiling the secrets of supermassive black holes, a revolutionary discovery. Get ready to embark on a fascinating journey into the heart of a distant galaxy. An international team of researchers, led by the brilliant Dr. Efthalia Traianu from Heidelberg University, has achieved a groundbreaking feat. They've captured an incredibly detailed photograph of the galaxy's core, offering us a glimpse into the mysterious world of supermassive black holes. For over a century and a half, astronomers have been perplexed by the OJ287 galaxy, located an astonishing 5 billion light-years away. Its unusual brightness fluctuations have been a puzzle, but now we might finally have an answer. The leading theory suggests that these variations are caused by a cosmic dance, a merger of two supermassive black holes at the galaxy's core. And this theory is supported by the team's remarkable image, captured using a space radio telescope. But here's where it gets controversial. The image reveals a previously unknown, sharply curved section of the plasma jet spiraling out from the galaxy's center. It's like a cosmic ribbon, and it offers us a fresh perspective on the extreme conditions surrounding these black holes. The OJ287 galaxy is a blazar, a highly active and bright galactic center. Black holes are the powerhouses behind these dynamic centers, drawing in matter and ejecting it as massive plasma jets. Cosmic radiation, heat, heavy atoms, and magnetic fields. It's a chaotic yet fascinating dance of energy. Dr. Traianu, a postdoctoral researcher at Heidelberg University's Interdisciplinary Center for Scientific Computing, emphasizes the uniqueness of this observation. We have never before seen such a detailed structure in the OJ287 galaxy. The image, which penetrates deep into the galaxy's core, exposes the jet's ribbon-like shape and provides new insights into the plasma jet's composition and activity. Some regions reach temperatures of 10 trillion degrees Kelvin, indicating the release of immense energy and movement near a black hole. And this is the part most people miss. The researchers also observed the creation, propagation, and collision of a new shock wave along the jet. This phenomenon is attributed to energy in the trillion electron-volt range, derived from an unusual gamma-ray observation made in 2017. To capture this radio image, the team utilized a ground space radio interferometer. This innovative setup included a radio telescope in Earth's orbit, specifically a 10-meter-long antenna from the RadioAstron mission on board the Spectre-R satellite, along with a network of 27 ground observatories spread across the globe. By effectively creating a virtual space telescope with a diameter 5 times that of Earth, the researchers achieved an incredible resolution. The vast distances between the individual radio observatories were key to this success, allowing for a measurement technique that leverages the wave nature of light and the interference patterns it creates. The interferometric image not only supports the existence of a twin supermassive black hole within galaxy OJ287, but also provides critical information about how the movements of these black holes influence the shape and orientation of the plasma jets they emit. The galaxy's special properties make it an ideal candidate for further research into merging black holes and the associated gravitational waves, Dr. Traianu stated. This study involved institutions from Germany, Italy, Russia, Spain, South Korea, and the United States, with backing from various research and funding institutions. The findings were published in the prestigious journal Astronomy and Astrophysics under the title Revealing a Ribbon-like Jet in OJ287 with RadioAstron. So what do you think? Are we witnessing a groundbreaking discovery that will reshape our understanding of supermassive black holes? Or is there another interpretation waiting to be uncovered? Feel free to share your thoughts and theories in the comments below.